Hi, welcome. Just in case you didn't see the chat, I'm going to start the session at 6:10, so that if there are others to join, they can also join, and then I can start for all of you together. All right, I don't think there are other people joining, so I think I'll start the session now. I hope I'm audible to both of you. Welcome to the problem solving session for the NPTEL course, Post Harvest Operations and Processing of Fruits, Vegetables, Spices, and Plantation Crop Products. So, if you are joining for the first time, I'll just explain how this works. So, there are two problem solving sessions for this NPTEL course. One happens on Sunday and one happens on Tuesday. It's taken by two different people. I am the one who takes the Tuesday session. I'm Anakha Nair and I am a PhD scholar in IIT Bombay. The session on Sunday and on Tuesday is the same. That means the questions that we'll be taking is the same. It's just it's different people who are taking it, and you can, depending on your availability, choose to attend either of the sessions. So how these sessions work is we'll be taking questions related to the module that you have learned this week. So these will be questions from the topics that you have learned, and we'll be going through them one by one, and we can clear any doubts that you have. And there'll be around 19 to 20 questions in each of these classes. So how this will work is I'll show you a question. I hope you will try to answer it. If you don't want to unmute yourself, you can just write it in the chat. So I'll be reading the chat. You can just write it in the chat, and then we'll see what the answer is, and then I'll explain how this answer came to be if there are any doubts. Okay. Most of these questions are theory related. So if you've attended the module sessions, then you will be able to answer them. All right. So if there are any doubts regarding the session, you can ask me now. Otherwise, I'll move on to the first question. Any questions, any doubts that you have, you can either unmute yourself and ask, or you can write it in the chat. All right. So yes. So I hope you will try to answer the questions that you see. So the first question is, which of the following is not a primary factor in hurdle technology? So there are four options: pH, water activity, temperature, and color. So what do you think the correct answer for this is?
4-1.
Fourth one, you saying? Okay. Uh, all right. So let's see what the answer is. So yes, color is the correct answer. So as you know, the hurdle technology is used for making sure the products last longer, right? So different hurdles can be used. In that case, pH as a hurdle can be used. You can make food acidic as a processing part, right? You can make it acidic so that it does not spoil fast. You can change the water activity by drying it, like you do with dry fruits, right? You can use temperature, that is, you can store it in cold temperatures, or you can do blanching. But color is not a primary factor involved in hurdle technology, right? So changing the color of the fruits or vegetables or any produce will not actually help in the case of preventing spoilage and increasing shelf life, right? Is there any doubt regarding this question? All right. So I'm assuming there are no doubts. So I'll move on to the next question. If there are any doubts, you can just write in the chat or unmute yourself. Either is okay with me. So question number two is, which of the following statement is are true regarding the principle of hurdle technology? And in the case where these sort of questions are there where you have to figure out which are true and which are false, unlike MCQ where there is only one answer, there might be multiple correct options in this, right? So keep that in mind while answering. So option number one is, hurdles distribute the homeostasis of. So hurdles disturb the homeostasis of microorganisms. Option 2, microorganisms can easily jump over multiple hurdles. Option 3, hurdles cause microorganisms to remain inactive or even die. And option number 4, Combination of hurdles prevent microbial growth. So out of these four options, which do you think is or are correct? You can try guessing also in case you're not very sure about it. You can write the answer that you think is correct in the chat also. Alright, I'm not seeing any answer as such in the chat. So maybe let's see what the answer is, right? So out of the four options, option two is the one which is incorrect, right? So hurdles do disturb the homeostasis of microorganisms, like changing acidity or placing the products in cold temperature, etc. Do disturb the homeostasis of the microorganism. They will not be able to get acclimatized to this new environment, and because of that, they will not be able to function properly, and therefore it will prevent spoilage, right? Hurdles cause microorganism to remain inactive or even die, which is also correct if you blanch the microorganisms. So, if you blanch fresh fruit for a short amount of time, or if you pasteurize milk, for example, it can kill the active microorganisms present in the milk or on the fruit, etc. Right? Combination of hurdles prevent microbial growth, which is also correct. So you can have preservatives, you can have heat treatment together, you can have multiple hurdles together, which will kill off different kinds of microorganisms, and it can prevent any sort of microbial growth, right? But microorganisms cannot easily jump over multiple hurdles. So this is incorrect. Okay. So microorganisms, if cannot, yeah, easily jump over multiple hurdles. So is there any doubt in this question? Just write no in the chat if you don't have any doubts. I'll get a clue. Alright, sure. So let's move on to question number three. This is a match the following type of question. So column one has the hurdles and column two has effects. So you have to match the hurdles in column one to the effects in column two. Alright. So column 1 has low pH, high temperature, low water activity and blanching. And column 2 has inhibits microbial growth, causes metabolic exhaustion, stress reaction in microbes, and disturbs homeostasis. So let's try this. Do you want to guess what the answer is? Do you want a little bit more time to try guessing? Alright, maybe let's see what the answer is then. So the correct answer is option A, right? Oh, D. Okay, D was not the correct answer in this case. The correct answer is option A. So low pH will inhibit the microbial growth, right? High temperature will disturb homeostasis of the microbes. Low water activity will cause metabolic exhaustion, and blanching will cause stress reaction in microbes. So blanching is when you are putting some product, right, in slightly hot water for a few minutes or a few seconds and then removing it, right? So that causes stress reaction in microbes, right? So uh, that and lower water activity will cause the removal of water from the surrounding, right? And in that case, because the solute concentration will be different, right, within the cell and outside cell. Yeah. So it will cause the microbes to produce, different ways in which they can combat that, and in that way, it will cause them metabolic exhaustion. Lower pH, a lot of microbes only work in certain pHs, right? So if you lower the pH, it will inhibit their microbial growth, right? And high temperature will disturb the homeostasis. It is a balance in which these microbes are present, right? So in that way, you have matched the hurdles with the effects, right? Any doubts in this question? All right. So let's move on to question number 4. Question number 4 is, which of the following statements is true about high hydrostatic pressure as a non-thermal hurdle? Okay. First option is high hydrostatic pressure is combined with antimicrobials to increase effectiveness. Option number 2 is high hydrostatic potential pressure alone can inactivate all types of microbes. And option number 3 is high hydrostatic pressure combined with heat reduces processing time. The processing time here is the amount of time you will, subject the product to the pressure to. So there can be one or multiple correct answers. Option A, all right. So maybe let's see what the answer is. So the correct answer is both option A as well as C. So 1 and 3 are the correct answers. So high hydrostatic pressure is combined with antimicrobials, right? So products like lysozymes, which will directly kill the microbes to increase its effectiveness, right? And high hydrostatic pressure can be combined with heat to reduce processing time. Okay, so if you increase the temperature at which this method is done, it will increase the amount of microbes that are killed or inactivated, right? But high hydrostatic pressure alone cannot inactivate all types of microbes. So it does not work on spores, right? They are resistant to pressure, right? So that was incorrect in this case. So if there are no doubts, I'll move on to question number, but it is given in the question as, huh. So in the question, it is saying that what is true about high hydrostatic pressure? Yes, but in the option, it is saying when combined with heat, right? High hydrostatic pressure is a non-thermal hurdle, but they're saying it work in the first question. It is working with antimicrobials, that is chemical hurdles, and in the third option, it's saying thermal hurdles along with the hydrostatic pressure. It it is two different things, but they combine together, right? Sure. So I'm assuming there are no doubts, and I'll move on to question number 5. Okay. So question number 5 is, which of the following statements are true regarding the effect of hurdle on microbial cells? There are four options. Low water activity leads to metabolic exhaustion. Low pH causes leakage of H plus ions. High temperature increases the production of stress shock proteins. And 4, blanching removes microbial spores. So you have to figure out which are the true statements in this. Again, it could be one or more than one. Try guessing what the answer is. If you don't know, if you know, you can just write in the chat what the answer is. Option 1, all right. So let's see what the answer is. So the answer is both option 1 and 2. So low water activity does lead to metabolic exhaustion. So that was one of the answers of a previous question too, right? And low pH causes leakage of H plus ions. That is also correct, right? High temperature increases the production of uh, stress shock proteins. Okay, and blanching removes microbial spores. So blanching by itself does not remove microbial spores, right? Because they are resistant to changes in temperature, right? So spores are not, affected by uh, microbial. Spores are not affected by, what was it? Blanching. Yes. So low water activity does lead to metabolic exhaustion. Low pH will cause a leakage of H plus ions, and high temperature does not increase stress shock proteins, but it can cause damage to microbial cells, right? So high temperature usually causes the production of heat shock proteins, okay, not stress shock proteins. um, so this is not correct, and blanching, removing microbial spores, is also not correct. Is there any doubt in this question? All right, so let's move on to question number 6. Which of the following statement is or are correct about pulsed electric field as a non-thermal hurdle method, where you're giving short bursts of electricity, right? So which of these are correct? First is high intensity PEF causes change in the cell membrane due to an electromagnetical instability. Option 2, combination of heat, lysozyme, and high intensity PEF are potential alternatives for heat sterilization. Option 3, the electric field and ionic strengths are not related to the poration rate and physical damage of the cell membranes. And option 4, pH changes the cytoplasmic condition due to the osmotic imbalance caused by poration. So, out of these, which one do you think is, or which one do you think are correct? Option 2. All right. Let's see maybe then what the answer is. So option 1, 2, and 4 are all correct. So high intensity PEF can cause changes in the cell membrane due to electromagnetical instability. So cell membranes are, made up of molecules like this, right, with positive and negative ends, right? And a change in this can occur due to a change in the electromagnetical instability that is caused by the pulse electric fields, right? So I don't know if you know that there is a process of electroporation, right? So if you want a DNA, a foreign DNA, to be transferred into a bacterial or other microbial cell, so you can do something called electroporation, where you apply short bursts of electricity to the cell, and it causes the cell surface to have pores on them, right? And that is caused due to such electromagnetical instability. So in short, a burst, if you give for very short amount of time, the cell will not die, but if you keep continue to give it, the cell will die, right? Because you have pores on the cell membrane and they don't close back if you keep giving electric impulse, right? Combination of heat, lysozymes are again enzymes which will lyse the cell, right? And high intensity PEF are potential alternatives for heat sterilization. That is also correct. Option number 3 is incorrect. The electric field and an ionic strength are related to the poration rate and physical damage to the cell membrane. So the higher the electric field and the higher the electronic ionic strength, the larger the poration rate will be, and the more damage it will cause the cell membrane, right? And pH changes the cytoplasmic condition due to the osmotic imbalance caused by poration. So if you have a cell which has pores in it, it will cause the leakage of ions, right? And that causes a osmotic imbalance. So a pH change will also occur in the cytoplasm, right? Are there any doubts in this question? I am assuming no, since I can't see anything in the chat. Okay, just stop me in case you have a doubt. Okay, so I'll move on to the next question then. So question number 7 is, which of the following statement is true about the combination of non-thermal hurdles? There are four options given to you. Combining non-thermal hurdles can enhance microbial inactivation. Option number 2, non-thermal hurdles can be combined with thermal methods. Option number 3, non-thermal hurdles alone are always sufficient for microbial inactivation. And option number 4, combination of hurdles can reduce the intensity needed for each hurdle. So out of these, which do you think is or are correct? Options 1 and 4, alright. So let's see what the correct answer is then. So in this case, 1 and 4 are correct, but 2 is also correct. So combining non-thermal hurdles can enhance microbial inactivation. So a change in pH, addition of antimicrobial enzymes or products, etc., together can enhance microbial inactivation, right? Because you can target the microbes in multiple different ways. So even if one kind fails, the another can be successful. Okay. So this is correct. Non-thermal hurdles can be combined with thermal methods. So in that case, when we were discussing about the electrical impulse or the pressure, right, you can add thermal methods such as heat shock, etc. And these two together can also be combined to enhance microbial inactivation, right? Option number 3, that is non-thermal hurdles alone are always sufficient for microbial inactivation, is not correct. So you might need some or the other kind of uh, hurdle, in which in this case it could be thermal hurdles or other kinds of hurdles also, and they work best when they're together. So in many cases, non-thermal hurdles alone might not be sufficient for microbial inactivation, right? Especially in cases where you have spores. So in these cases, non-thermal hurdles might not be by themselves sufficient. Option number 4 is combination of hurdles can reduce the intensity needed for each hurdle. So if you needed around, let's say, 1 unit of lysozyme, right? But you have combined it with pressure, right? So you might need less than 1 unit now, right? So the amount of lysozyme that you have to use is less, or the pH that you have to bring it down to can be less, or the amount of pressure that you have to put on the product is also less, right? So you can combine hurdles to reduce the intensity needed for each hurdle. Any doubts in this question? All right. So let's move on to question number 8 then. What is the water activity range of maple syrup? So you might be knowing that maple syrup, in the case you'll pour it on pancakes, right? So it's gotten from the sap of the maple tree, and you boil it for a long time to get the thick syrup, right? So you have to tell me what the water activity range for maple syrup is, and there are four options given to you. Option A being very low water activity, and in increasing order. So B is slightly higher increasing amount of water activity, C is little bit more increasing, and D is little bit more increasing. So what is the water activity range of maple syrup? So this might be a theoretical question that you might remember only if you have kept track of the data, right? So maybe I'll go directly on to the answer itself. So the water activity range for maple syrup is about 0.82 to 0.86. Okay. So this is a not a very high water activity. It's a moderate, a little bit higher than moderate water activity. And in this range, botulism, etc., the bacteria that is responsible for botulism, etc., cannot survive in this, right? So the act of boiling of the maple syrup to make a condensed maple sap to make a condensed syrup has decreased the water activity to this range, right? So let's move on to question number 9. I'm assuming there are no doubts in this. Okay. So question number 9 is, which of the following is a characteristic of intermediate moisture foods? So food containing intermediate quantities of moisture, or or the moisture content of these fruits is in the intermediate range. So there are four options given to you. Water activity is above 0.90. Moisture content is between 20 to 50%. Option C is microbiologically not stable at room temperature. And option D is low sugar content. So which is a characteristic of intermediate moisture foods? I can give you a clue. This is a MCQ, so there's only one correct answer. Would you like to try guessing again? Alright, so maybe let's see what the answer is. Okay. So the correct answer is the moisture content is between 20 to 50 range. The intermediate part of this question should have given you a clue as to this, right? So since it's saying it's in between the very low moisture containing foods and the very high moisture containing foods, this is the range at which these intermediate moisture foods are present, right? The water activity is not above 0.90. That is in the case of high moisture foods. High moisture foods have a water activity of 0.90, right? And above. Microbiologically not stable at room temperature, that is also not correct. So since they are intermediate moisture foods, that is their moisture content is in the intermediate range, they are much more stable at room temperature than high moisture foods, right? And the low sugar content is also not correct. So that is a product of the fruit or the product itself, and not uh, a product of the moisture being removed, right? So the sugar content is not related to that. So the correct answer is option B. All right. So if there are any doubts, you can let me know. Otherwise, I'll move on to the next question. Right. So question number 10 is, which of the following statement is or are correct about antimicrobial packaging, right? So there are four options given to you. Antimicrobial packaging does not affect the growth of microorganisms. Option B is antimicrobial packaging works by killing or inhibiting the growth of pathogenic microorganisms in food. Option C is the absorption mode in antimicrobial packaging releases antimicrobial agents into the food. And option D is immobilization mode allows the migration of antimicrobial agents in the food. So, which of the following statements is or are correct? Try guessing. All right. So I'm not seeing any answers. Maybe we'll go to the answer itself. So the correct answer is option B. Antimicrobial packaging works by killing or inhibiting the growth of pathogenic microorganisms in food, right? So as the name itself is suggesting, it is antimicrobial, right? Option A, that is antimicrobial packaging, does not affect the growth of microorganisms, therefore is not correct, right? Antimicrobial packaging does affect the growth of microorganisms. It either kills the microorganisms or it inhibits their growth, right? Option C, the adsorption mode in antimicrobial packaging releases antimicrobial agents into food, and option D, immobilization mode allows the migration of antimicrobial agents into food is also not correct. And why it's not correct is, so the mode of actions for antimicrobial packaging is of three types, where there is release, there is absorption, and there is immobilization, right? So in release, what happens is it allows migration of antimicrobial agents, right? So that there might be some antimicrobial agents, okay, in the packaging itself, and it allows the release of these into the food or headspace inside the packages, and it inhibits the growth of microorganisms, right? Adsorption, how it works is removes factors of microbial growth that are essential for the microbes to grow from the food system, right? And because they have removed these factors, it will inhibit the growth of microorganisms. And the last one, that is immobilization, is when the antimicrobial agents are immobilized, right, on the surface of the packaging, but they can suppress the growth of microorganism in which it is in contact with, but it does not release it directly into the food. Okay. So in this case, since it is saying immobilization allows the migration, which is not correct. If it was saying release, then that would have been correct. And the absorption mode in antimicrobial packaging releases, that is also not correct. It removes essential factors from the food that the microbes can use for their growth. Okay. So in both cases, they are talking about the release type of antimicrobial packaging, not the adsorption or the immobilization type. So the only one correct in this case is option number B. Alright. So if there are any doubts, you can ask me. Alright. So let's move on to question number 11. Question number 11 is, which of the following effect is or are achieved by applying edible coatings on fresh cut produce? So fresh cut fruits and vegetables, if you apply an edible coating on them, which what does it achieve? So option 1 is reducing the respiration rate. Option 2, increasing melinaldehyde and electrolyte leakage. Option 3 is preserving phytonutrients and discoloration retention. And option 4 is controlling post-harvest decay. So applying an edible coating leads to which of these following things? Option 1 and 3, alright. So maybe let's see what the answer is. So option 1 and 3 is correct, but controlling post-harvest decay is also correct. So since you are reducing the respiration rate, and since you are preserving the phytonutrients, and you are not giving a chance, you're coating the fresh cut produce, and it will not allow more microorganisms to come and settle on it to spoil it, etc., right? So you are controlling post harvest decay also, but it does not increase the malondialdehyde and electrolyte leakage. In fact, it prevents it. All right. So this is not correct. Any doubts in this question? Right. So I'll assume there are no doubts. So let's move on to question number 12. Question number 12 is, which of the following methods are used for producing intermediate moisture foods? like we had discussed before, these are foods which have moisture content in the intermediate range, right? So there are four options given to you: partial drying, osmotic dehydration, fermentation, and vacuum impregnation. So what do you think the correct option is or are? B. Alright. So let's see what the correct answer is. So the correct answer is partial drying. So if you have food with a higher water content, you can partially dry it by applying some form of heat, dry heat to it, so that the water is evaporated from it. Uh, Osmotic dehydration, in which assume there is a tank or a container which has a solution of sugar, okay, and you place a fruit in it. So what happens is the water from inside the fruit will move into the solution, right? Because it has lower water potential, right? So in that case, the water, since it is moving from the fruit to the solution, it will become a intermediate moisture food, right? Fermentation is not changing the moisture content of the food as such. It is changing the flavor profile and the pH of the fruits and vegetables, right? And vacuum impregnation is you keep a fruit in a vacuum chamber and remove all the air bubbles from it, and then you uh, place a liquid while in vacuum, and when you release the vacuum, the liquid will go into the places that the air molecules had released, okay. So in that way, if it is a dry fruit, you can increase the moisture to reach a intermediate moisture content level, right? Any doubts in this question? So fermentation is not a correct answer for this. Okay. So I'm assuming no doubts, right? So I'll move on to question number 13. Question number 13 is, what is the typical water activity range for high moisture fruit products? And there are four options given to you. So do you want to try guessing the answer? E. All right. So maybe let's see the answer. So since they're talking about high moisture fruit products, right? So they have high water activity also, right? So because of that, they fall in this range. 0.85 to 0.98 is high water activity, right? The 0.30 and 0.50 are low water activity, and that is in low moisture fruit products, not high moisture fruit products. Do you have a doubt in this question? All right. So I think I'll move on to question number 14. Question number 14 is, which of the following statements is or are true about high moisture fruit products? Okay. So first is they can be stabilized using combined hurdle technology. The second option is the pH range of these is typically between 3.0 and 4.1, that is acidic. Option 3 is high water activity alone is sufficient to inhibit microbial growth. And option 4 is combination of high water activity and low pH is effective in preserving high moisture fruit products. So what do you think is correct about the statements regarding the high moisture fruit products? Option 1, all right. maybe let's see what the answer is then. So the answer is 1, 2, and 4. So these fruit products can be stabilized using combined hurdle technology. You can have multiple hurdles together, thermal, non-thermal. They can work on them, right? So you can pasteurize fruit juices. You can also add preservatives into them. They're two different hurdle technologies, right? To stabilize them. Option number two, that is the pH range of these high moisture fruit products is usually acidic so that microbial growth does not happen because the water content in these or the water activity of these products is high, right? So the pH is deliberately kept at a lower range so that microbes cannot thrive in this high water activity environment, and therefore high water activity of these products is not sufficient to inhibit microbial growth. Instead, in usual cases, high water activity is beneficial for microbial growth. But when it is combined with low pH, it is effective in preserving the high moisture fruit products. Okay. So by itself, water activity, a high water activity will not inhibit microbial growth. But when it is combined with low pH, like it is in the case we see in these products, it is effective in preserving these, fruit products, the high moisture fruit products. Is there any doubt in this question? All right. So let's move on to question number 15 then. Question number 15 is, in a fruit slurry, total moles of water, which is given by Nw, is 8 moles, and total moles of sugar, which is given by Ns, is 4 moles. That is moles of water and moles of solute, right? What is the water activity of the fruit slurry? So if you know the formula, you can try answering. All right, I'm not seeing any answers. Do you want a little bit more time to solve this? Or should I go directly to the answer? Just let me know. I'll give you time to solve in case you want it. Alright, I'm not seeing any response in the chat, so I'm assuming you want time to solve this. Is that what it means? Alright, so maybe let's move on to the answer then. So the answer is 0.75. So how did we come to this answer? Let's see that. Alright, so the formula that we have to use in this case for water activity, that is EW. EW is equal to NW by NW plus NS. Okay, so maybe I'll write the formula better once more. AW equals to NW by NW plus NS. Alright, so In this case, you just have to input the data that is given already in the question into the formula. So NW, that is the total number of moles of water, is given as 8 moles. All right. So wherever NW is there, you will write 8. And NS, that is the total mole of sugar or solute in this case, is 4 moles. Right. So you have 8 by 12, right, which is 2 by 3, right, which is almost equal to 0.75. So the nearest answer to this question will be 0.75. Okay, so therefore the water activity of this fruit slurry is approximately 0.75. Was that clear? Are there any doubts in this question? All right, so I'm assuming there are no doubts. I'm not seeing anything in the chat. All right, so let's move on to question number 16. Just a second. Uh, I think the answer itself is given in the question, but let's anyways see the question, right? So, which of the following method is are used in the preservation of high moisture fruit products? There are four options given to you: use of preservatives, high pressure processing, passive packaging, and traditional canning. So, the correct answer in this case is already given here: the use of preservatives and high pressure processing, right? In which case, imagine it's a fruit that you're processing, right? And you're applying pressure from all directions. So, the shape of the product itself is not changing, but the use of the pressured environment will kill or inactivate any microbe that is present on the surface, right? So they will die, but the fruit itself will not change shape because the pressure is from equally applied from all sides, right? Passive packaging is not going to work as a preservation method. Active packaging, where you're using antimicrobial packaging, etc., right, they will work, but passive packaging will not. Just packaging a high moisture fruit product will not uh, is not a method used for preservation. And traditional canning is also not used as a method for preservation of high moisture fruit products. Okay, any doubts in this question? So traditional canning is not used for um, preservation of uh, high moisture fruit products. So can you think of a way, like a reason why it is not? First, let's try that maybe. Any idea why canning is not? Anyone else? You want to try because things like chickpea is packaged with water, but chickpea is not a high moisture fruit product, right? Pineapple, yes. We have seen pineapple, yes. So in most cases, why it is not the method that is always used for preserving high moisture fruit products. Even pineapple is a um, not a very high moisture content fruit, right? So very high moisture content fruit will be something like mango, right, which has a large quantity of water content in it, right? So in that case, in this case, that I mean, why is canning not suitable for these products? First of all, in a lot of canning, it involves thermal sterilization, okay, in the range of 100 to maybe 100, and like when you're autoclaving, right? So certain temperatures like this. So for several minutes you'll have to do thermal sterilization of the product before they are canned. Otherwise, when you can them, right, and you're providing the environment, the microbes might grow, right? So before that you will have to thermal sterilize the product. Okay, this will alter the texture, texture, the flavor, the color, okay, of products. So in the case of high moisture fruit products, this change in the texture, flavor, etc. is very high. Okay, so that's why you might not find canned mango, right? Because the flavor profile does change. And fruits, a slightly drier fruits like peaches or pineapples are still better for this, right? And there might also be nutrient losses in the product. Okay, um, it is canning is a method which we use for like shelf stable products. Okay, so it has to be stored without refrigeration, right? So, high moisture fruit products are usually products that you will store in chilled temperatures, okay, and they have short shelf life. So, in that case, canning is not necessarily a good way of preserving. You have better ways of preserving these foods than canning. Okay, all right. So, let's move on to question number 17. So, which of the following is not a novel preservation technique used for high moisture fruit products? There are four options given to you: high pressure processing, plasma treatment, UV radiation, and open air drying. So, which is not novel? What is it that is not usually used? Option C. All right. Do you want to try guessing again, maybe? All right. Let's see. B. All right. So let's see what the answer is. So the correct answer in this case is open air drying, right? So it is not usually used as a preservation technique for high moisture food products, right? So high pressure processing, like I had discussed, where you are putting pressure on the product equally from all sides to kill the microbes on the surface, but not change the shape or the texture of the fruit or vegetable drastically, right? Plasma treatment, uh, again, it is where you use ionized gas, right? Cold ionized gas to inactivate the microbes on the surface. And because it's cold ionization, it does not change the flavor profile of the fruits and vegetables, right? It has a very minimal effect on the food quality, right? Same thing with high pressure processing. UV radiation, you will know that UV radiation changes the DNA structure of like the structure of DNA, right? And in microbes, because their reproductive rate is high, replication rate is high, changes in the DNA structure can be deleterious when they are, bombarded with UV radiation. So that can kill the uh, microbes present on the fruits and products. Now, open air drying is not a novel technique, right? It has been used. First of all, open air drying is a technique that has been used for centuries to remove moisture from food, right? It's not a novel technique. These are novel techniques, relatively new, right? So, and high moisture fruit products are telling you that you are selling these products in a high moisture state itself, right? So open air drying, therefore, is decreasing the moisture content of the fruit products, right? So they don't remain high moisture fruit products. So therefore, open air drying is not used as a way uh, to preserve these products, right? All right. So, is there any doubt in this question? All right. So let's go to question number 18 then. Question number 18 is, which of the following statements about plasma treatment in food preservation is correct? So option 1 is plasma treatment uses ionized gas to inactivate microbes. Option 2 is it is effective at low temperatures. Option 3 is plasma treatment is not suitable for solid foods. And option 4 is it can improve the shelf life of fresh produce. So what do you think is the correct answer in this case? 1, 2, and 4. All right. So let's see what the correct answer is. So yes, 1, 2, and 4 is the correct answer. Well done. So plasma treatment does use ionized gas to inactivate microbes. Ionized gas treatment is usually given at low temperatures, so it's also known as cold plasma treatment, right? Plasma treatment is not suitable for solid foods is not correct. It is very suitable for solid foods, and it can improve the shelf life of fresh produce is also correct, right? Because it is deactivating or killing the microbes that are present on the surface. So in that way, it can improve the shelf life of the produce. It will prevent rotting. Okay. Any doubts in this question? All right. So let's move on to the final question for today, which is question number 19. So the question is, which of the following statements about the processing of fresh cut produce is or are correct? Option 1, which is the goal of an optimum peeling operation includes minimizing product losses, heat ring formation, chemical usage, and environmental pollution. Option 2 is peeling methods are manual, mechanical, chemical, enzymatic, and thermal. Option 3 is factors affecting the cutting operation include the sharpness of cutting tool, type of size reduction, direction of cutting, and geothermic shape of fresh cut fruits and vegetables. Sorry, geometric shapes. Option 4 is the goal of an optimum peeling operation does not include minimizing environmental pollution. So, what do you think the correct option is or are? Option 1 and 3. All right. Anyone has any other answer? So let's see what the answer is. So the correct answer is option 1, 2, and 3. So the goal of an optimum peeling operation does include minimizing product losses. So if you have this much of a fruit, imagine you're peeling an apple, right? Wait, a shape of an apple, right? And you have to peel this. So if you peel this much area, right, there, that is a product loss, right? And you're getting less product, so that should not happen. uh, Heat ring formation, again, because the automatic peeling operations can produce heat, right? So there should not be heat damage to the produce. Okay, so you have to calculate the energy, that is the maximum heat that these products can take, in where these products will not be hurt, right? I mean, these products will not be denatured, or the flavor profile or the texture will not change as such, right? The chemical usage that you're using, because peeling can be done using enzymes and other chemical methods also, right? So how much of these chemicals are you using, and the environmental pollution that is caused by whatever rejects of this entire process are there. Okay. Peeling methods are manual. You can do it using hand, mechanical using sliding knife or a blade, chemical, um, alkali treatment, etc. Enzymatic, uh, enzymes which will break down the topmost layer of fruits and vegetables like pectin, etc. And thermal, right? So if you blanch fruits or you uh, certain fruits like tomato, if you blanch them, the skin will peel off, right? Option 3, that is factors affecting the cutting operation include the sharpness of the cutting tool, yes. Types of size reduction, yes. Direction of cutting, yes. And geometric shapes of fresh cut fruits and vegetables. So if it's a very straightforward cutting, if it's like round, it is easier to cut, right? But if it is some weird shape, imagine there are certain fruits that are in star shape. I don't remember its name, but if it is this case, etc., it might be difficult to cut, right? Because of the shape of the fruit itself. So this is also correct, right? Because the cutting operation does include, you have to include all these things. And option number 4, the goal of an optimum peeling operation does not include minimizing environmental pollution is not correct. So it does include minimizing the environmental pollution. You don't want to pollute the environment more than required for this, right? So in this case, yeah. So this was the last question for today. Do you have any doubts in any of the questions or any other doubts for today or this module? If I know, I will try to answer it. Do you want me to repeat any of the slides or the questions, or do you have any doubts in any of them, or anything that you want to? Ma'am, can you show me the first question? Sure. Yeah. So the first question is, which of the following is not a primary factor involved in hurdle technology? And the correct answer is color, because the color does not affect the hurdle technologies, right? pH, water activity, temperature does. Do you want to see any other question? All right, sure. So, any other doubts from anyone else? I'm not seeing anything in the chat, so I'm assuming there are no doubts. So, thank you so much for joining everyone today. It was a pleasure having you. So, this is it for today's session. So, these are all the questions that I was meant to take. You can leave the chat if you don't have any questions or anything that you want to discuss. The same kind of session will be there for the next module next week on Tuesday, which I'll be taking, and on Sunday, which another TA will be taking. The questions will be the same, so you can join whichever you want depending on your availability. All right. So, thank you so much. Thank you. Thank you. So I'll stay in the meeting for a little longer so that if there are any others to join, I can clear their doubts. Hi. So I finished all the questions. Question number 19 was the final question. Do you have any doubts in any of the questions, or do you want me to repeat any of them? I hope I'm audible.